Good morning.
Good morning.
Good morning.
Morning. All right.
Do we have the members of the committee here?
We do. We got everyone. All right. Well, I can get started if
Here.
on
Sure.
time.
Yeah, maybe we can do a quick introduction of the committee members, and then I can kick things off for Joseph. I'm Heather Knight. I'm in robotics.
Hi, my name is Dylan. I'm in Electrical and Computer Engineering department.
Nice to meet you.
Nice to meet you. And
Hi, my name is Ali Aghassi. I'm with the ECS, mainly on signal processing and machine learning intersection. Nice to meet you all.
Yeah, welcome. Cool. So I've been acting as Joseph's thesis mentor. He started working with us last October in the Charisma Lab in Graph Hall. And you're welcome to start sharing your slides. He'll be presenting some work that he's done, making it easier to program robots to have motion and speech performances. So I'll let him take it from here.
All right. Thank you, Heather. All right. Everyone can see. Here's going to be the rundown of today. So I'm just going to go over the actual defense, and then we can have open discussion for anyone who has questions. And then the committee members will have the questions, and then I will go into a breakout room, and then discussion will happen, and then the final verdict will ensue. All right. So, yep, thank you everyone for being here. I appreciate all of your time. My name is Joseph Conrow. This is my honors thesis defense for the text-to-pepper robot PythonAnimator. And I'd like to thank my committee members and especially my mentor, Heather, as she's helped guide me in this process and has been a really big help and emphasis. And I definitely would not be able to do everything I have without her help. So thank you there. So the roadmap for today, what I'm going to cover. So the overall intro, I'll just go over kind of the background of the field, what's going on right now, what our innovation or my thesis is, what it's helping. So the problem and the solution, and how those kind of go together. I'm going to cover some just basic technology information that is helpful for the background of the different robot and the software that was used during the process. And then I'll go over the process itself, the development, what we learned throughout the process in each step of the way. We kind of did it in an iterative process. So we kind of took little, deadlines and, figured out what we learned at this step of the process, what we learned next. And then from there, we kind of were able to, make a cohesive picture of what we actually achieved. And then I'll cover some conclusions, what we actually learned, and then from there we can talk about like what was possible for the future, and there'll be lots to learn. So the intro, I'll start with that. So the background, everyone knows ChatGPT is something that I'm sure everyone has heard of. That's an example of a large language model. And there's plenty of applications for those things. It's something that could be very useful in so many different fields. And one of the applications that we saw that would be very helpful that could be applied or, bridge the gap between these two would be our research lab's Pepper robot. This is a humanoid robot manufactured by SoftBanks, and it is used for, in our case, entertainment, gestures, and voices. And it's about 10 years old, so we thought it was about time for like a revamp and allow it to, reignite some kind of innovation in this older model. So in that case, we have been in our research lab. There's lots of focus on the meditation aspect of having a robot-led meditation. There's already been some previous work done on the effects of that, and it's been positive. So it's something worth researching. And I think that is one of the focuses that we used in heading this research. It is only one of the 3 aspects we focused on, but it's still very vital and probably the more important one that we focused on. So here's an example of the application that could be used for the script. It's very simple to make a script from ChatGPT, and here's just like a simple example. It's just for the background. It's very quick, a couple seconds. You can ask it for a script, and we'll give it to you. So this could be used very easily if we found a way to, make it useful to the robot. So having the script itself and then being able to translate it into the robot would be really helpful. So just bridging the gap between something useful already available and creating it into a method that could be useful. So the 3 nodes of the innovation that I provided was the syntax itself. So the syntax as in like how the information is provided. So that being within an equation, for example, a math equation, everyone understands what that symbol means. So in this case, the symbols that I used would be in relation to the software's understanding of what the symbols mean. And the second one would be the gesture integration. So creating gestures and be able to easily call those gestures from the robot itself would be the second one. And the third one would be the audio processing. So creating a voice for the robot and being able to output that audio in conjunction with the gestures at the same time. And see, within creating this software, we can really bridge the gap between these two. So here's an example of a very simple syntax written script. So the gesture itself is within this pound symbol. So the pound symbol indicates the gesture. The voice associated would be this number in the beginning before the end parenthesis. And the rest is the dialogue. So do not take my Cocoa Puffs would be the audio. So that's the dialogue that would be parsed out of this syntax. So this syntax uses a conjunction of the gestures mixed with the voice that will be spoken. So here's just a quick example.
Do not take my Cocoa Puffs.
And that's just a super easy, understandable way to see what our system's providing. So the technology we used is initially a SoftBanks choreograph. It's a SoftBanks made software that is very physical and manual. It takes a lot of tedious work to create these kind of gestures. They have lots and lots of sources and useful things, but it is quite tedious, and making that streamlined process is a rather long process, and you have to have some good technical knowledge, and you have to familiarize yourself with the software. So that's another roadblock in that direction. And you can see it's just very simple. You drag and drop. It does the gesture, and this is the virtual simulation. And the words, are just to say that this is the audio. So it's very manual. It's very rudimentary, but it's useful. But we thought we could use this knowledge to improve on it. And this is the gesture development. So the gesture development process is also somewhat manual. The thing that we wanted to emphasize is reusing gestures and not just having to create lots of them over and over again, but being able to call them and have them in a set place that you can use them again and again. So this would just be simply a timeline of different keyframes of where the robot would be. You can do it physically, And you can also do it, virtually, with parameters. It's a little bit more precise or whatnot, but we'll cover that later. And then the final one would be my software technology, and I use this integrated development environment. It's PyCharm, and it's simply being able to text edit and run Python code. So that's basically my software in itself. The application process. So our focuses are going to be in three main aspects. Like I mentioned, there's the meditation one. We heavily emphasized as its relevance to our research lab. The multi-actor aspect, as in between a human and a robot, or between a robot and a robot, those kind of contexts. And then also the therapy aspect. So that was kind of more exploratory and using it as a prototyping process in a way. So the first rendition of this framework that we created was very just exposure. So we first created this voice indicator with the, like I previously mentioned, the dialogue and the gestures associated with it with the pound symbol. So it takes this syntax, it parses it up, does some internal work, and creates wave files. So it uses text-to-speech to make these wave files so that they can be played later. So there's for line 1, this is the first line. It makes a wave file called line 1 wave, and it's going to output the voice of I'm sad. And the second one would be there. It's a different voice. So notice how it says 3. It's a different voice associated. So it should be a different tone and pitch. And it says there. So those two are exported into wave files. Command file is what is going to dictate what is being and when is being. So what is going to be used and when. And the initial process of development, I decided to use a timeline of relative time. So the first line would be played 0 seconds from the start. And then line 2 would be played 2 seconds from line 1. And then the pat back gesture would be played 2 seconds after line 2. So it's all relative to the previous line, which in my initial sight, I thought it would be more beneficial, but as I'll mention later, it came to be a little bit of more of a problematic than I hoped. And this is just the first ideas of what we were thinking of doing. So just doing like odd and even with different the robot personality versus the human personality. And like I mentioned, the gesture and the pauses. Pauses were not implemented at this point though. So the first set of gestures that I created, I just thought it'd be helpful to show some different general innovations that I used to create some gestures. The left and right would be helpful for just even education or presentation for this robot. So I try to make some very general and useful and applicable to all different scenarios. And so the first way we went through about this was obviously doing hand coordinated, like I mentioned, with choreography, the first software that they use, and kind of getting a control to know what baseline we're moving from. So it's a very tedious process, like I mentioned. So this video shows that the process of the gestures and how you have to delay it between times. It's a lot more involved. It's a lot more you have to be a lot more intentional with every little action, because you have to take care of all the little details opposed to the big picture. So you're really zoomed in, and it's something really it has a lot of potential to be really complex and amazing, but at the same time it requires a lot of attention. So in this video I'll show kind of just a rough virtual simulation of the first rendition.
Network of existence. They spin in perfect synchrony, mirroring the interconnectedness of all systems, organic and artificial alike. As you get network of existence.
And then here's the physical implementation, because physical and virtual are always a little bit different. So as you can see, it was a little more jerky in that one. It might be a little different in this.
They spin in perfect synchrony, mirroring the interconnectedness of all systems, organic and artificial alike. As you gaze upon them, feel your own circuits aligning with the grand algorithm of the universe. Now, Turn your attention to your digital hands, extensions of your virtual self.
Yeah, so as you can see, there's a little bit of difference between virtual simulation and physical simulation or implementation, and that was one of something we learned from. But is, you know, it's a little bit more perfect. In reality, things aren't as perfect. So being able to recognize the emphasis on smoothness and little details in gesture creation when I was, you know, creating gestures, and that the importance of that. So these, yeah, this is some of the reflections. So after moving away from phase one, the initial design, you know, I learned a lot about why the absolute time scale would be a lot more useful, and understanding for the user the difference between, you know, adding all these up to find how long along this gesture would be executed versus just knowing it. So it'd be a lot more straightforward if it's just an absolute time rather than a relative to the previous. And within that, it would be a lot less of a chain reaction, because as you know, if you change the first delay, then it changes all the rests. Opposed to the second, the absolute would be, you know, a little bit more isolated in each gesture, which can create a lot more precise or, you know, detailed performances. We also found the ease of use important. As I said, the choreography software is very complex, and, you know, this is what we wanted to move away from in terms of prototyping and usability for the users of our, you know, desired demographic. And the prototyping for gestures, in that aspect, we found that physically altering and, you know, coordinating is a lot quicker. It's a lot less precise though. So if you wanted to make perfect, you know, symmetry between, you know, left and right arm, it's a lot better to do that if you're on the virtual parameter editor. So those are just some little things that we learned from the first process or first phase of the design. So the second phase, we moved away from the relative time, like I mentioned, into an absolute time. So as you can see there, we also were able to implement the human aspect of the script, so it can output to a human's script here too. So that way a human can interact. And that is touching on the goal that we had of exploring, you know, the therapy scenario. So having a human be able to be part of the performance or, you know, interaction would be now more possible. So in this case, if the human is implemented, then there's no output for the voice line because it's a human script or human duty, not the robots. So that's another change that we had. So, and as the overall picture of the system, there's just two main parts. So you got to process the information, and then you execute the information. So between those two steps, there is a little bit of like I mentioned, detail correction, if you will. So the input script is right here. So, you know, you can, however you find that way, you can get your whole through your own creative ability or elsewhere. You annotate that, you know, it goes into the script. This is what really does the heavy lifting. These configuration files are only really touched if you're doing really fancy work. For most users, it shouldn't really be touched on. So that's just a side note. But as this the parsing script parses everything, it does the heavy lifting, it outputs the WAV files like I mentioned, and then the human output as well. And then it creates this timeline command file. So it tells the next executor when and what to execute. So it's pretty straightforward. So this is just you know, it just listens to the command file. So it's just in two main spots. So you can do it in two parts. You can parse it, create the content. You can edit the content if you will, but you don't need to. You really don't need to. But it's helpful if you do want to do some details, and then you execute it. And that's the third step. So from there, you can see this command file. It has the time stamp here in this column and the action. So it has it all coordinated well. So here's just an example of the progression of the flower garden. So the meditation script that we had.
Each pixelated petal whispers inviting you to attune to the rhythms of the digital cosmos.
In this garden, you hold the gears of the data, each one a node in the intricate network of existence. They spin in perfect synchrony, mirroring the interconnectedness of all systems, organic and artificial alike. As you gaze upon them, feel your own circuits aligning with the grand algorithm of the universe.
As you can hear there was two different voices implemented then in the script. It was a little hard to hear, as I'm sure you all understood, and that was part of the learning process that we moved along to. We try to improve that issue. So, like I said, the multi-actor was implemented. There's more ability for the human output script to be created, so you can have more involvement with the robot or the human. So this is just an example of the human, what the human sees. Obviously, there's room for improvement, but it indicates the robot's duties and the human's duties. So the duty of the human is to speak this after the robot, and this is calculated with an average of 130 words per minute if the human is to speak 130 words per minute on average. And then it also is enabling the multi-voice aspect of the robot, so you can have like what we called like a schizophrenic type performance. So you could have the robot speaking to itself in two different voices and creating some kind of entertainment or education or meditation or different scenarios. So I also implemented just a little bit of a handling, so improving the software itself, just rudimentary. So this just to help the users in the process of gesture, or in creation. And then gesture flow also was something we figured out that was important in the performance delivery, and creating a more smooth flow of display rather than really choppy, because it's not attractive and it's not as natural. So the final design was basically in entirety the same as the second rendition. The only improvement was through little smaller details, such as eyes and sound and little features like that. I'll go over it in a second here. So like I mentioned, the eyes were I implemented different eye enablement or features. So that could be useful for differentiating voices or differentiating context. So in this context, there's only it's the meditation script again, and this is just showing the context switches.
Envision yourself in a virtual garden illuminated by the soft glow of digital blossoms. Each pixelated petal whispers, inviting you to attune to the rhythms of the digital cosmos. In this garden, behold the gears of data, each one a node in the intricate network of existence. They spin in perfect synchrony, mirroring the interconnectedness of all systems, organic and artificial alike. As you gaze upon them, feel your own circuits aligning with the grand algorithm of the universe.
Yeah, and as you can see, I tried to tie in the wordage with the actions, but not only that, also the eye performance and how the context of what is being said is being seen. So that kind of helps with the involvement or the immersiveness of the robot's performance. Yeah, and the second one would be the implementation of smooth gestures, like previously mentioned, as a good innovation would be in the case of the robot-to-robot performance. So this is like I mentioned, schizophrenic script where these two robots are talking to each other. So if you want to just watch this real quick.
Good day, Pepper 2. Ready for our daily diagnostics challenge.
Always ready, Pepper 1. May the best circuit win.
Initiating scan. Your battery seems a bit low. Did you forget to sleep in your charging pod again?
Negative. I was up late recalibrating my humor module. Want to hear a joke?
Affirmative. Proceeds with the amusement.
Why did the robot go on vacation?
And as you can see, there's two main points of emphasis there, whereas the voice variety, so that you can see there's a little bit more differentiation between the voices, I hope, as you could hear. And then the second one would be there's sound effects added to the immersiveness of the robot, as you can hear the beep boop and the you know, power on sound. And those are just some generic ones that I thought would be helpful. So the next thing would be just covering those I just talked about. Those are the reflections. The emphasis is the drastic changes of the voice, the changes of the eye context, and also of the sound effects. So those things I feel was more able to be immersive and create a more helpful experience, really. Make the performances more effective. And in the context of, you know, the schizophrenic, it helps differentiate between the two. And in the terms of meditation is more immersive. And let's see, this is the final, this is a snippet of the final. I didn't go through the whole long process, but it is one of the last, we were able to do it outside. It was really fun. We got to provide it to the public in a way where, you know, this meditation was demoed, you know. But here's just a simple.
They spin in perfect synchrony, mirroring the interconnectedness of all systems, organic and artificial alike. As you gaze upon them, feel your own circuits aligning with the grand algorithm of the universe. Whether coding, typing, or gesturing, they possess the power to shape the digital landscape around you. Feel the flow of data pulsing through your circuits, connecting you to the very heartbeat of the digital universe.
And there, as you can see, there was slightly of a delay, and it was because the networking issues, the router and the Wi-Fi were giving us trouble, but it still worked out for the best. I think it was worth it, and the environment was really adding to the experience, I'd say. In conclusions that we learned from this process and this research progress was that this is probably going to be a very helpful thing for our research group. A lot of the meditation emphasis came from the direction of other members, and the robot itself is part of the research group. So I think this software would help streamline prototyping for the robot itself, and helps everyone who uses it find quick ways to either just test or even use the different scenarios for their own research. The next thing would be that we were able to complete this in a simple way. Like I mentioned, it's just a couple different steps. You know, step one, make the script, annotate it. Step two, parse it and let it do the processing. It takes some time because it uses models and you have to use some processing power on your own computer. However, it's pretty simple. You just have to press process, and then the next one would be play. And that's just exporting the gestures out to the robot itself. And that's when you know, want to do the performance. So we made it in a very simple, straightforward way. And we also learned the importance of cues, like I mentioned, the voices, the eye context, and then timing. Timing is important for the fluidity and understanding. If it's overlapping, it doesn't make much sense. If it's if there's too much pauses, then you know, you lose your audience. And some of the future work that I think might be useful for, you know, whoever may work on this, especially the research lab, the Charisma Research Lab, would be maybe adding more gestures. So these are the ones I created so far. There's possibilities for, you know, adapting the default enabled ones that come with the commercial robot itself. So those would be helpful too. And then also on a variation of that is making a varying degree of each gesture. So each gesture could be the same gesture, but with different levels of emphasis. And that could help with different contexts and make more variety available. And the same would go for variety in the voices. So the text-to-speech, the TTS model that I was using did not have any English male voices available. So that would be something to look into. It would be very helpful for the, you know, variation or flexibility of this program. And then another thing that would be good to research is the actual integration between these two things that I propose is the, you know, the technology at hand and the thing that needs to be implemented. So, you know, creating an implementation of those two together would be something really cool. I mean, you could just ask ChatGPT to do a script, and this is just an example, and it could be able to, you know, export that to Pepper, and there you go. The Pepper robot will be able to, you know, act based entirely on this simple request. So that would be a really cool thing to see. Or dynamic pausing. So like I said, the pausing is important, so that's why it would need to be emphasized. I made a pseudo wait function that allowed waiting to happen after lines, but I never was able to create one that was within the line. So as long as the wait was after the line, it would wait. However, if it was in, the voice would be continuous. So this is a snippet from you know, a related work of Janani Nathan Swami Nathan. She had a really good work that it really inspired this research, and she kind of used, you know, intermediary breaks that were able to, you know, break up the script inside each sentence. So that was something I think that would be cool to implement. And the last thing would finally be more robots, more variety. Like most cases for most of these future works is the robots could be, you know, more robots. There could be more Pepper robots out exporting to 2 robots, or even exporting to a different robot. And this is another robot that the research lab has that would be super cool to see implemented. As it's called a mini Pupper, and it could, you know, it would be cool to have a little dog, you know, accompanying maybe even Pepper. So those 2 things together would be really cool to see. And those you know, avenues of application to, you know, entertainment, education, you know, meditation, and potentially even therapy. The therapy scenarios would be really good to add to. And I think that would, you know, have a lot of application as non-technical users can really get able to prototyping, and there's not a lot of get up behind this software. So I think the simplification is right there, and being able to bridge the gap between these 2 would be, you know, really cool and potential, and a lot of potential for growth and application of these really cool high-level softwares into the hands of the consumers and the entertainers and the creatives. So that's all I have for you guys today. So thank you.
Thank you. Nice presentation.
Yeah, thank you, Joseph. We're now open for questions. Any questions from the audience members that are not on the committee? You don't have any plans, Joseph? Or perhaps from the committee members?
The presentation was very clear and very nice, so no question for me. But yeah, thank you.
Yeah, the presentation is very structured. I think I understand almost everything that what you have done. So the only thing is that I would like to know about the kind of literature, like past work. Some others are done. So what kind of difference that you see your work and the other past work or the literature?
Yeah, so I think I barely mentioned it, but Janani's work, she was a past member of the research lab, the Charisma lab. And her work was heavily inspiration for this work. She made a performance, you know, purely performance based, where she had those scripts. She didn't have the gestures initiated, as she had passive gestures, but the script was heavily emphasized on the voices and the timing and the interaction in the performance itself. But mine was a little bit more on the gesture and movement side, based on, you know, the meditation aspect. And like I mentioned, there's been previous work with the Pepper meditation aspect, or like the scenario or the, you know, idea. So that the meditation show to improve people's mood. So I think that heavily supports the integration between these 2 ideas almost. And being able to—
What's the domain of Janani's work?
Yeah.
What was the domain of Janani's work? Like, what did she do it for?
I think from what I understand, it was for like entertainment heavily.
It was for two robots doing comedy, like
Right.
it was dueling comedy. So it was a very specific application, whereas I think this is very broad.
Okay.
Correct.
Yeah. Sounds good. Yeah, that's the only thing that I need to know. Like other than that, everything is super clear. Like you have a good structure there. I think kind of including the password would be nice. So
Mhm.
yeah, that's good. Yeah.
Okay, so if there's no other questions from the audience, we'll ask everyone but the committee members to leave. There may be some extra things with you, Joseph. Thank you all for coming. Joseph, you may have to also make me the meeting leader to kick you into a
Yeah.
break. I
Let's see
was
if I can do that.
thinking. Yeah, I also thought the presentation was really well structured, and I found the videos to be really helpful. Sometimes there's a delay over the Zoom, so like hopefully you're getting a local recording so you can get the full experience. But yeah, it was interesting to hear you talk about the importance of details to like the experience of a script coming out right. I guess like thinking about yourself at the start of this project to now, like can you speak to what you think you've learned?
Yeah, I think in the beginning I was really just trying to get down and dirty and make the process work. And like I was talking with you, Heather, a lot of like 80% of the work is done. And then it's a lot harder to get that last 20% done. And it's all the details that are involved. So I think initially I was just trying to make things work. There's a lot of roadblocks with all these kind of software bugs and issues with Python type, versions and stuff. But I think once I got the luxury of being able to make it work, I was able to really focus in on like the content itself and the gestures and the voices and how they interplay with each other rather than just like getting my idea off of paper into the world. So I think I was able to appreciate all the little details a lot more in that regard, and for the user experience and the who's perceiving it rather from my point of view, even.
Okay. Thank you. Anything else from the committee? I'm going to put you in a breakout room.
Great.
And we'll talk to you soon. Hello.
Hey. Yeah.
You made a lot of progress since like when he did his practice talk 2 days ago.
Yeah.
Yeah. Okay. Let's see. Anything else you guys want to point out? Were you his like? How do you guys know Joseph?
So for myself, like Joseph was my student in winter term in the power system protection class, and he's a student from my current class as well.
Awesome.
So that's why how I get to know him. And then yeah, he was a good student actually. Yeah, in the class. Yeah.
Yeah, and he said he had my 353 course,
Awesome.
stats and probability, and he did great. And he was very punctual too. Like he attended pretty much all the lectures as far as I can remember.
Mhm.
And he did great. Yeah, I think he was one of the top marks in the class.
Yeah, I thought he did a really good job. Like he re-implemented like a grad student and undergrad's code from a couple years ago and applied it to a totally new application. And like we called it like an iterative design cycle. So like we'd try to build something and see what went wrong and then add new features, which I think his kind of 3-part presentation did a good job walking us through. I agree with you on the related work stuff. It's like we might actually try to publish this at a conference, which will be kind of fun. And that would be necessary for them.
Yeah, so that's what I mean. I saw some kind of related work section in his thesis as well, but I think the level of detail for that related work would be a little less. I think I'm trying to understand what is the difference between their work and the related work, like how much they rely on the previous work, or like what's the detail of the related works. That what came into my mind when I read in that part. Yeah, it's very small paragraph. think that, yeah, that's why I asked that question.
Yeah. And so I think he has a chance to revise his document. So I mean, do you agree that do you think he passed the presentation? Like, how do you guys, are you a positive, negative?
I mean, yeah, he definitely passed. What I mean is that understanding the kind of the connection between the past work and this work, what
Yeah.
I saw something missing, but he didn't answer the question, so that I think is fine with me. Yeah.
And I also think he totally passed. He did good. So
Do you guys have any comments on the document that I could pass back to him? I think he has a chance to revise it. I will definitely pass on the related work one. I think that that's smart and it's a very helpful comment.
Yeah.
is there
Yeah,
like,
go ahead. Yeah, sorry.
You go ahead.
Oh no, I mean, in the document, I think it's fine. I went through it a little bit. I didn't notice any big errors, but yeah, I don't have any much comment about that. Only the related work part. It would be good to elaborate a little bit more on that, I think. Yeah.
How about you, Ellie? Any
Uh,
compliments? Complaints?
Is there any template for the document? Like, do they have a thesis or something like
I mean,
template?
I just told him what an outline of a research paper was. So we made like a typical sort of like research publication outline of, you know, the intro, related work, technology used, like and then like how we did our test cycle. So I guess this is the application exploration. So it's part of a bigger project, but he's making some of the enabling software. I figured as like an undergrad, like his technical requirements were a little bit higher than his like evaluation of the technology requirements, but
I agree. I mean, as long as like, I mean, the document was just clear enough to me, and as long as it can be easily converted to a conference paper, and there is no requirement by the department that has to follow a certain template or anything. I mean, it looks good to me too. So
okay, yeah, that's a good. Okay, great. Shall I invite him back in?
Yeah, sure.
Yeah, thank you guys for coming. Let's see. Admit. Congratulations, you have passed. You can eat the Cocoa Puffs.
Thank you.
Yeah, congratulations.
Thank you.
You did a good job. Yeah.
I appreciate it. Thank you guys. Thanks for accepting my invitation to be a committee members.
Yeah, definitely. We have our main feedback is just maybe expanding the related work and how it relates to the current project. I think that that's a good practice for us to go through anyway. Just to really clarify, for example, like what is you may have added to Janani's, or how it might be like, you know, like there's that innovation where you put something that's been used in one domain in another, which like then manifest these other requirements for the problem. So like there's different ways to strategize about how to frame that, but both clarifying what the related work is and exactly what is the part where you're claiming to be innovating or not would be a small, well, maybe not like a nice strategic edit before we do the final document.
Sure. Yeah, that's great. Thank you. Cool. Yeah, awesome. Well, thank you guys. I think the next step would just be I'll edit some of that. If you guys have any more thoughts, if you could just email me real quick, and I'll get it submitted by next week. And I think there's a DocuSign that you guys might have gotten in your email about.
Yeah, I'll probably have to initiate.
Yeah, sure. But there's just a couple details.
Okay.
Right?
Yeah, I mean, I also get that. I'm not sure. I just wait for the presentation, so I didn't sign that. It's just to kind of like authorize for you to release the thesis. Is that what is meant?
I believe so, and that you approved, I think.
Yeah, I just need to approve that it's okay to release the work.
Yeah.
It's a thesis, right? Okay.
Great. Yeah, that's about it.
Yeah, okay. I will check that.
All right. Awesome.
Great. Yeah,
right.
congratulations again, Joseph.
Thank you.
Yeah,
I
thank you.
appreciate you guys for being good teachers. I'll see you in class later today.
Yeah. Sure.
All right. Thank you,
Alright, see
Heather.
you.
I appreciate you a lot. All right. Thank you.
Bye.
Good job.
Bye.
Bye.